Now we're going to look at actually what covalent bonds look like. Alright, so let's think here about Legos. The shape of the object that you want to build is limited based on the way the blocks of Legos connect together. And when we go to build a molecule and actually see what a molecule looks like, which is of course the covalent bond, it's very similar. They can only connect in so many different ways. The only thing we've looked at so far is an ionic bond, and they make those crystal lattices, and they have a nice set patterns. Well, for molecular structures or covalent bonds, you end up with these different models that you can have as to how to depict a covalent bond. We have what's called a molecular formula, which is pretty much the formula right now. We have space-filling models, which are the more visual, where the bigger the size of the atom, the more space it takes up. You can have a structural formula, which just connects the P's and the H's together, or the atoms together. You have a Lewis structure, which actually shows the electrons and the lone pairs. And then you can have what's called the ball and stick molecular model, where we have sticks in between to connect the two atoms. And you're not seeing different sizes here, just spheres on the end. So the most useful structure is probably what we call a Lewis structure. And that's a term that I have used before, but the Lewis structure is just a way to connect all of the atoms together, and it also shows you all of the electrons. Okay, you can see where all the valence electrons are, or where all the lone pairs are. That's probably the most useful one. So what we're going to look at now is how to kind of draw these Lewis structures. When you go to draw a Lewis structure, you have 5 steps. The first step is you predict the location of certain atoms. Okay, the lowest electronegativity, which remember that means lower electronegativity is further from fluorine, is the center. Other things like hydrogen are always on the end. Halogens are usually on the end, but not always. The second step then is to determine the number of electrons available for bonding. So what I look at is the total number of valence electrons in all the atoms. That's why it's total. Look at everything you've got. You add them all up. Remember, valence electrons you figure out based on the group number. Then I place the bonding pairs, which means you place a bond between the center and all of the terminal atoms, which means all of the ones on the end. So now I've got them all connected. Now you got to check, okay? And you have to figure out, once they're all connected, how many electrons are remaining. So you take the total number of electrons, you're going to subtract the number of electrons used just to connect them together. And that will be your number left over. And all of those leftover electrons, the remaining ones, are going to be lone pairs or double bonds or triple bonds. They can be lone pairs around the terminal atoms, or they can be lone pairs on the center atom. And in order to know exactly where to put these lone pairs or these electrons, okay, we look at our center atom. And we determine whether the center atom satisfies the octet rule, meaning does it have 8 electrons? If it doesn't, add lone pairs, add a double bond, things like that. And remember, C, N, O, and S are the most common ones that will do a double or a triple bond. And we're going to look more at those later on. So let's start off easy. We're going to look at single bond Lewis structures. So we start with NH3. Okay, N's in group 15. It's got 5 valence electrons. Hydrogen's in group 1. It has 1 valence electron, but I have 3 hydrogens. So 5 plus 3 times 1, I have a total of 8 electrons. That's my total number of electrons that are available to bond. Now I figure out, okay, what probably goes in the center? 1 N or 3 H's? H's are never in the center. N is in the center, and I connect all of my N to the H's. Now I've used 2, 4, 6 electrons, 2 in each one. So 8 minus the 6 that I've used, I have 2 electrons left. Well, where are they going to go? Hydrogens are all happy here. They have 2 electrons around them. But nitrogen only has 6, so we add a lone pair for 8 around nitrogen. Okay, if I look at CH3Cl, count up my total. Carbon is 4, each hydrogen is 1 for 3, and chlorine is in group 17, so it has 7. Got a total of 14 electrons. Well, now it's going to go in the middle. Well, what's the least electronegative? Carbon. If there's a carbon, carbon goes in the middle. And then I connect everything. See, H, 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 Cl. I know this chlorine cannot be hooked onto an H because H's are never in the middle. H's only ever have 2 electrons. And I count. 2, 4, 6, 8. There's 8 electrons that I've used. I have 6 left. Where are they going to go? H's are all happy, carbon's happy, chlorine's not. Chlorine only has 2 electrons around it. It needs a total of 8 around it. Now it's got 8. Now I've used 14 electrons. Go ahead here and try NF3. Okay, now notice how I've used 26 electrons here. And it looks very similar to this NH3, just with fluorines instead of hydrogens. Now I'll look at multiple bonds for Lewis structures, because these are all going to be examples that we're going to see. So I start off the same, add them up. Carbon is 4, oxygens are 6, there's 2 of them for 12, total of 16 electrons. Carbon is the least electronegative, plus it's a carbon, so it goes in the middle. I connect it to both O's. Now I've only used 4. I now then have 12 electrons left to place around. But everything still needs 8. Well, if I start off and give everything a lone pair, so that everything has 8, that's way too many electrons. Everything's got 8, so it's happy, but that's more than 12 electrons that I need to use. So what we look at now is multiple bonding. So we're going to get rid of some of these. And we're instead now going to try double bond. Now carbon's happy with 8, because each line is 2. Now I've used 2, 4, 6, 8 total. Okay. So now I've got 8 left to put around. Well, if I go 2 here and 2 here, that's 8 for this oxygen. 2 here, 2 here, that's 8 for that oxygen. Now I've used all 16, and I had to use a multiple bond. Now let's look at the next one. C2H4, total of 12 electrons. I've got 2 carbons here. This one's a little bit different. We end up having 2 centers with each hydrogen attached to the carbon. Again, because the hydrogens cannot be in a row, so they end up being 1 on each end. Why is it not 3 on one end, 1 on the other? Because they tend to be symmetrical. Look at how many I've got here. 2, 4, 6, 8, 10. I only have 2 more electrons to go, but both of these guys here need 8. So what do? Add a double bond in the middle. Go ahead and try the last one. Notice how oxygen and sulfur are in the same group. Very similar structures as CO2 and CS2. Alright, let's go ahead and draw the Lewis structures for the polyatomic ions. First thing we're going to do, okay, is remember that when we look at polyatomic ions, these are all covalently bonded. So it's nothing new. What we do have to be careful is that they are ions. Well, if it's a positive ion, that means that we need to lose electrons. So we subtract from the total. If I have a negative ion, that means I'm going to gain electrons, so you add to total. So let's try here. So look at P. P has 5. OH has 6. There's 4 of them, 24. And then we have to add 3 more to it. So my total there should be 32 electrons. All phosphorus is going to go in the middle. Go 4 around the outside with the O's we connect. I haven't quite used up my 32, so I try and give everything 8. All of my dots. Give every oxygen 8. This phosphorus already has 8, so it's happy. And if I count all those up, that's going to be 32. Sometimes you'll see these ions in brackets, like a big bracket, and then it'll have like the 3 minus on the outside. They just do that to make sure that you know that that's supposed to be an ion. I don't make you do that, just draw the Lewis structure. So why don't you go ahead and try the last 2. And there's what your last 2 should look like. Okay, so the all together practice is 1 of everything. Why don't you go ahead and try these. Add up the total number, connect everything together, and then see what you've got left. And there's what you should get for the last 3.